Okay, finish the week off. We're going to be proving that parallel lines exist. Actually, we're going to prove that two lines are parallel. Now, there's ways that we can prove that. We're going to talk about those ways, and then we'll look at some example problems that we're going to get here. But the thing you got to understand is, for us to be able to move forward, for us to be able to look at triangles and quadrilaterals and all these other shapes, we have to be able to prove that we have parallel lines. Because then if I have parallel lines, I can use those terms that we just got done talking about. I can use that corresponding angles postulate, or the alternate interior angles theorem, or the consecutive interior angles theorem. I can use those to help me prove different things about our different shapes. So we've got to be able to show that we do have parallel lines. And that's what we're going to start off with here today. So let's get looking at these right now. What are the ways to prove two lines are parallel? One way is to show that they have the same slope. We've already done that. That's what we were doing back when we did the coordinate proofs. We showed that two lines have the same slope. That was one way to prove that two lines are parallel. Now the other way is to use postulates or theorems. And that's what we want to look at today is what are the postulates and theorems that can help us out with this. So the first thing we have to understand is this postulate 3.5. It's 3.5. It's not 3.4 because that's what it should be. It's 3.5. It's called the parallel postulate. And if a given line and a point not on a line, then there exists exactly one line through the point that is parallel to the given line. That is a fundamental postulate in geometry. So if I have a line and I have some other point, I can get one line through that point that's parallel to the line I already know. That's important. I've got to be able to do that. I've got to be able to draw a parallel line through another point at some point. And this postulate allows us to do that. Now, where do I go from there? So now I can draw a line that is parallel. So what are some of the theorems or postulates we have? We have the corresponding angles converse postulate. Notice the word converse there, because the corresponding angles postulate says if I have two parallel lines and they're cut by a transversal. This is the converse of that. Here it just says if I have two lines in a plane that are cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. So the big thing here that you got to catch on here is that now I know I have congruent angles, which means I have parallel lines. So if I know the angles, I want to use the converse postulate to show that I have parallel lines. Now the other one was the corresponding angles postulate said if two parallel lines are cut by a transversal. That was a couple videos back. If I had parallel lines to begin with, I used the original postulate. If I want to show I have parallel lines, I use the converse postulate. So this is saying if 1 and 5 are congruent, M and N are parallel. If 2 and 6 are congruent, M and N are parallel. If 3 and 7 are congruent, M and M are parallel. If 4 and 8 are congruent, then M and N are parallel. All it takes is one of those pairs, and it got it. Because the postulate said so that a set of corresponding angles. One set is all it takes. So now let's look at another theorem. This is a theorem, theorem 3.5. If two lines in a plane are cut by a transversal so that the pair of alternate exterior angles is congruent, then the two lines are parallel. Notice we're given angles first, parallel lines second. That means this is going to be a converse theorem. So the alternate exterior angles converse theorem says I'm going to get parallel lines if the converse angles are congruent. So in other words, for our figure up here, if angle 1 is congruent to angle 8, or angle 2 is congruent to angle 7, then M is parallel to N. If the alternate exterior angles are, that works. And then we got theorem 3.6. If two lines in a plane are cut by a transversal so that a pair of consecutive interior angles is supplementary, consecutive interior angles supplementary, then the lines are parallel. Again, I'm ending with parallel lines. I'm starting with angles, so it's a converse. So we can either call this consecutive interior angles or same side, whichever you want to use, angles converse theorem. So that is saying if the measure of angle 3 plus the measure of angle 5 equals 180, or if the measure of angle 4 plus the measure of angle 6 equals 180, then M is parallel to N. It just takes one of those things to happen. Yeah, let's slide it up. We got one more theorem to deal with here. And it says if two lines in a plane are cut by a transversal so that a pair, there it is again, of alternate interior angles is congruent. So if angle 3 is congruent to angle 6, or if angle 4 is congruent to angle 5, then M is parallel to N. Switch that color. Okay? Now, again, we were given angles and we got parallel lines out of it. So that's a converse theorem. I call it the alternate interior angles converse theorem. Excuse me. So those are the 4 theorems that kind of go with what we already talked about. But there was another theorem that we talked about before. If we had parallel lines and we had a perpendicular. So there's one other way we can do this. What if we go the other way? What if in a plane, if 2 lines are perpendicular to the same line? Then they have to be parallel. I refer to this as the perpendicular transversal converse theorem. So I have 2 lines that are perpendicular to the same line, I get parallel lines. If I have alternate interior angles that are congruent, I get parallel lines. Every one of these, anytime I'm trying to prove 2 lines are parallel, I'm going to use a converse theorem. The regular theorems are if I knew I had parallel lines. So what kind of examples are we going to have? You're going to get something like this. I've got this figure. Eyeballing it, it looks like T and K are parallel. It looks like M and L are parallel. But we want to prove that they're parallel. We need to use one of those theorems that we just had, or postulates from above, to say that they're congruent. So here's the way I do this. So A says angle 1 is congruent to angle 5. So the first thing I do is I identify those 2 angles, angle 1 and angle 5. And then I identify the transversal. What line connects angle 1 to angle 5? That would be T. So T is my transversal. So if T is my transversal, that would mean that M would have to be parallel to L if angle 1 and angle 5 are a particular kind of angle. Well, angle 1 and angle 5 are not between M and L, so they're exterior, and they're on the opposite sides, so they are alternate exterior angles. So alternate exterior angles converse theorem would prove that. And that's the way I do every one of these. I identify the angles first, and then I go from there. So angle 8 and angle 11, angle 8 and angle 11 add up to be 180. This is one of those quick giveaways. There's only one set of angles that add up to be 180 that gives us parallel lines. And that's the same side interior, or consecutive interior. So that would be the converse theorem if this is going to work. Now, that would have to be the theorem. The question is, I got that in the wrong spot, same side should be right there. Are 8 and 11 same side or consecutive interior angles? Well, what line connects those 2 angles together? That would be M. M connects them, so M's the transversal. 8 and 11 are on 2 different equations, are on 2 different lines. So that would mean T is parallel to K. Now, let's look at the next problem. I've got angle 6 is congruent to angle 14. Again, first thing I want to do is identify my 2 angles. I notice where they're at. What line connects those 2 angles? Is that line right there. So L is my transversal. If L is the transversal, that means T would have to be parallel to K if anything's going to work. Now, what kind of angles are 6 and 14? 6 and 14 happen to be alternate interior angles. And then it's the converse theorem. So if you can identify the angle pair, you know which theorem to use to get to the parallel lines. And that's our whole trick behind doing this. Now, let's look at the next one. Ooh, erase my board. I've got angle 18 plus angle 11 equaling 180. So the first thing I do is I identify my 2 angles. And here's what I notice. They're both on one intersection. They're on the same intersection. So this cannot be determined. You can't figure this one out because 8 and 11 just adding up to 180 doesn't give me parallel lines. 18 and 11 are just linear pairs. So that's a no-go. Cannot be determined. Now what if I had angle 16 and angle 12. Angle 16 and angle 12. Again, they look like they're on line K. They're both on different lines, so that would mean LM is parallel to L. And what kind of angles are 12 and 16? They're alternate interior angles again. And the converse theorem would then prove the lines are parallel. Okay. One last problem here to look at. Our angles are 1 and 15. Angle 1 and 15. Okay, what line connects those two lines? So that would be our transversal. There's not a line that connects those two. We have to have a transversal to use any of the theorems that we've had. We don't have a transversal. We don't have any theorem to back us up. So we have to say it cannot be determined. That's what you're going to be doing on the assignment. But you're also going to have some proofs where you would have to prove that this happened to work out. And we can talk about those in class.